So the next thing we're going to be talking about in section 10.2 are series. And a series is formed when terms of a sequence are added up. So an arithmetic series, okay, is the sum of terms in an arithmetic sequence. So if we had a sequence like 1, 5, 9, 13, and so on, if I added all those up, that would be considered my arithmetic series. So a series is just a single number, okay? Now, the sum of the first n terms is called a partial series. We call that partial because it's not the whole thing, right? And we denote a partial series as S sub n, right? Okay, so here are a couple important formulas that we use to find the sum of series, right? So the first one, if we know the first term and the last term, okay? First term and last term, then we're going to use this guy right here. S sub n, or the partial series, is equal to n times the quantity a1, so the first term, plus the last term divided by 2. So basically what it does is it finds the average of our terms and multiplies it by how many there are. Okay, and the reason that is because we have a common difference. For every one you go up by, you're going to come down from the final term. And so basically you just find what the average is and multiply it by how many numbers there are, right? Okay, now another way is if we don't know the last term, let's say we don't know the last term, but we know the first term and we know the common difference, we can also find our partial series. And it's using this formula where you take n divided by 2, so the number of terms you have divided by 2, then you multiply it by 2 times the first term plus the common difference times n minus 1, okay? Now, right now they might look a little scary and they might look like a lot of stuff. But as we work with them, you'll get a little bit more comfortable and get a better feeling for finding these partial sums, okay? All right, so let's use them in an example. All right, so example 4, it says find the sum of this series. Now, what do we know? I know the first term, okay? So A1 is 12. That's what I know. I know the last one is 180. Now, the question is, do I know how many numbers are in this? I do not, right? I could figure that out. And I use it to figure that out. What I'm going to do is I'm going to say, okay, well, what would I add to 12 to get 19? Or what would I add to 19 to get 26? Or another way you could do it is just subtract. You do 19 minus 12, second minus the first number, and that's 7. So my common difference is 7. Now, let's go back to the formula and plug in our numbers as we can. So the first formula that we had, we needed to know n, the number of terms, which in our case, I guess we don't. We needed to know the first term, and we needed to know the last term, okay? So if I look at this, and I look at the second equation, I also need to know n. So I know for a fact, I'm going to need to know how many numbers are in this sequence. So that's the next important thing, okay? So let's use our equation of series, right, or sequences, and we know that that was an is equal to a1 plus n minus 1 times the common difference. So we'll plug in the numbers that we know. Well, we know the last term is 180. We know the first term is 12. We don't know what n is, but we do know that the common difference is 7. Okay, so how can we evaluate this a little bit more? Okay, well, what we're going to do is we're going to distribute the 7. And so we end up getting 180 is equal to 12 plus 7n minus 7. Okay? Now, if we combine our like terms, 12 and 7, that ends up being 5. So we get 180 is equal to 7n plus 5. Okay? We solve it like any moron problem. We subtract 5. We get 175 is equal to 7n. And we take our calculator and we do 175 divided by 7. We get n equals 25. Okay? So you might think, okay, sweet, so we got 25, but what does that mean? Because we're supposed to find the sum of that series. Okay, so let's write that down. So n is now 25. We know that. So now I have my first term, I have my last term, and I have n. So now I can use that first equation of partial series to figure out the sum. So let's do that. Okay, so let's look at that example, or that formula, excuse me. That formula said S sub n, I'll use a different color here. S sub n is equal to n times a1 plus an over 2. So let's plug our numbers in. Okay, so our numbers are n is 25 times the first term, which is 12, plus the last term, 180, divided by 2. And I find that my series, when I put this in my calculator, 25 times 12 plus 180 divided by 2. When I put that in, I get 2400. So what is the sum of my partial series? It's 2400. Now, you could write all 25 numbers out, and then you could add them all up. That sounds like a lot of work, but you could do it. You really could. And you'd get 2400. All right, very good. All right, example 5. Find the first three terms of an arithmetic series in which a1 is 7, a1 is 79, and we know S of n is 430. Okay, so we need to figure out what the number of terms there are, and then once we know that, then we could figure out the common difference and we could find the first three terms, right? So let's look at that. So our equation for S of n is equal to n times a1 plus an over 2, right? So I'm going to plug in the numbers that I know. I know 430 is our partial sum. I don't know n, but I know that my first term is 7, my last term is 79, and obviously 2 is just 2. So I simplify by getting 430 is equal to 7 plus 79 divided by 2 is 43. So I get 43 times n. Easy math would tell you that n is going to be 10. Okay, so we know that there's 10 numbers in our sequence. So if I know that there's 10 numbers in my sequence, and I know that the first one is 7, and the last one is 79, I can figure out the common difference. Okay, and so I do that by going back to that original arithmetic sequence equation. Very important to have. A sub n is equal to a sub 1 plus n minus 1 times d. And so now we're looking for d. And so we plug in the numbers we know. We know the last term is 79. The first term is 7 plus, well, n is 10. 10 minus 1 times d. Well, we know 10 minus 1 is really just 9, right? Oop, and that should be an equal sign. Okay, so 79 is equal to 7 plus 9d. We subtract 7. We get 72 is equal to 9 times the common difference. Divide by 9. And we find that the common difference, d, is going to be 8. And so if I know the common difference is 8, I can find the first three terms, right? So a1 is going to be 7. Make some room here. a1 is going to be 7. a2 is going to be 7 plus 8, which is 15. And a3 is going to be 15 plus 8, which is 23. So those are the first three terms of our sequence. And again, we could continue to make all, I guess, 10 of them in the sequence, add them up to make sure they add up to 430.